length, so it's a multiple scales. Coming to the building levels, going to the occupants part, and also we cannot consider the building as an isolate, so they have an interaction also with the grid and the HVAC system. So we have to consider whole of this process as a system. In the beginning, to better understanding the whole of this process, we start in the lecture review from the different aspects to go into the boundary condition, the different methodology they use, the stakeholder KPIs, technology, and also the scale of the research they done based on the previous researcher. And we found the three main gaps. Most of this research just relying on the one single methodology for using for the prediction of the future. So they ignoring this uncertainty. The another part, they not be multi-scales and also considering the urban interaction of the building. And most of the research, they considering the static facade technology. They didn't come moving for the adaptive with the considering the HVAC dynamic and the grid decarbonization scenario. To answer in these parts, the primary objective of this research is developing the performance-based methodology for designing the climate adaptive heat resilience building envelope, drawing the systematic uncertainty quantification with the multi-criteria assessment and also robustness analysis. To reach this objective, we face it with several questions. The first question, how do different weather file generation methodology influence on the building performance prediction with the and facade design optimization? The second question, it's based on the first, is which kind of the facade design strategy remain robust during this multi-climate projection methodology, time horizon, and also stakeholder priorities? In the third one, can the performance-based framework be extended from the envelope to the building scale and access the complex dynamic facade component? And the last part, how we can do the grid decarbonization pathway and HVAC performance degradation influencing these facade technology selection. And to answer in the research question and to reach our objective, we start in the lecture review from the different scales. So in the first part, we're moving on the climate change in the building performance and the weather data generation methodology, thermal resilience, KPIs. So we defined some uncertainty and we're moving to the quantify, how the weather file generation methodology propagate in the facade design in the building performance. In the second part, we understanding this uncertainty. We try to answer that with the robustness analysis. So doing the lecture review in the different uncertainty and robustness in the building design and facade for the climate resilience during the regret-based decision theory. And we extended this regret-based robustness for the multi-climate, multi-stakeholder facade optimization with adding the urban scale heat release. And the last part, we try to think about how we can validate and extend our framework from the building and the zone level to the design of the facade component, so for the different scales. For each kind of this step, we try to extend our simulation-based methodology. In the first one, we're just focusing on the zone scale and sensitivity analysis with the 3 different KPIs. In the second, we extend our methodology to the full factorial with the multi-criteria weight analysis. And the last part, we added in the other effect from the building scale, HVAC system degradation, grid, GH emission factor, and also the complex dynamic facade method. First article that's published in the building environment, that's focusing to answering our first question, how do the different future weather file generation methodology can influence on the building performance prediction and also the facade design optimization. This research that's focusing on the different methodology for the producing the future weather files coming from the original climate model RCM. It's a dynamical downscaling that's following the Annex 18 methodology, and another method coming from the morphing as a representative for the CC weather generator. It's coming from the shift and stretch the TMWise file. And the next part coming to stochastic generation is a methanol. So using the sum interpolation to producing the future weather files in the 3 time horizon of the current, mid, and far future. With the 3 main KPIs coming from the energy use intensity, indoor hour heating degree, and added in the new KPIs, the heat releasing from the buildings. These files we try to remain in the earlier stage of the design. So we creating the different combination of the facade parameters and using the sensitivity analysis. That's a combination of the Sobol and standard regression coefficient. For the creating the sample of the method, we're using the lighting hypercube sampling, which is the best test of the 600. To add in some idea about the new KPIs of the heat releasing from the building, based on this conceptual, each kind of the building have a 3 main aspects that they're releasing this heat coming from the HVAC system based on the which kind of the HVAC you want to use, coming from the zone, it's the exfiltration and exhaust air, and coming to the facade from the is the convection and the long wave radiation. So in this research, and the second one, when you're talking about the heat release, it's mean the total heat release. That's the sum of all these 3 main aspects divided by the area of the facade part. So in the next, we try to understanding what's the effect of this on the each KPIs. In the energy, that's a moderate between the 12 to 46% differences if you're using the different kind of the methodology for the producing weather files on the when you're moving from the current to the mid and the far futures. But the extreme part, when you're going to the indoor hour heating degree from the comfort, it's more than 400% differences between the distribution of your result. And the most stable, it's coming from the heat releasing from the building between 2 to 60% differences. The another perspective, we try to look at the result, it's the effect of the ranking of the facade strategy from the different weather file in the time horizon and also from the KPIs perspective. We are understanding the most of this facade strategy we're using for this specific case study. It's the constant between the different kind of the weather file. So if you're using the different methodology from the ranking perspective, you're reaching the same answer just from the different KPIs. We have some interaction. For example, when you're moving to window hour ratio, we for each kind of this KPI, we have a different approach and a different kind of the ranking you receive that. So we have a 3 main, like a 3 top 3 parameters, the G value, shading, and the window hour ratio. It's a constant, but from the different weather files, but we have some interaction between when you're moving from the building to the environment of the, if you increase the term window hour ratio, the heat releasing is the crazy and the energy is increasing. So we have some interaction that cannot be solved with this approach. So the main result of this research is coming from when you're moving from the different perspective, the distribution of your result from the absolute value based on each KPIs is a differences, but the ranking of the facade strategy is a constant. In the next part, we try to understanding why these differences. When you look at the IOHD and indoor hour heating, we understand it's mostly dependent on the peak of the temperature, and each kind of this methodology give you the different kind of the peak. From the EUI, when you're moving in the long term and the yearly, when you comparing the distribution of the air temperature, relative humidity, and solar radiation, we haven't any big differences between the different methodology. And the heat release is coming mostly dependent on the surface temperature and also the outdoor air temperature. That's the differences between them. So we have not the big differences. That's the showing us, okay, we have some limitation in this research. It's a single just location for the Torino is the mostly dependent on the balance between the heating and the cooling. And we using the equal weight for all the KPIs, energy in the IOHD and also the heat release. And the showing, okay, this sensitivity analysis, the showing, okay, this stability in the ranking, they cannot solve in the interaction and the conflict, especially for the window wall ratios. So based on that, we're understanding this decision support for the moving to the next part. We understanding we have uncertainty, but we didn't know how we can answer to that. So we choosing another methodology to how we can deal with the uncertainty. So that's pushing us to creating the second research to answering this question, which kind of this facade design strategy remain robust across the multiple climate projection methodology, time horizon, and also stakeholder priorities. As a previous one, we keep the three kind of the methodology, but extended the city to the Rome and also the belt. In the rather than the sampling method, we move into the full factorial analysis, but using the same performance simulation. But here we added in the two phase for the optimization. But before showing the result, we have to understanding in the min-max regret or in the regret methodology, we didn't think about the best performance and the best design. We look at the design with the lowest regret choosing, okay, regardless of which kind of the uncertainty future will be materialized. And also we try to add it in the three main optimization paradigm from the performance optimize or not robustness optimize, or if I using the hybrid optimize, we're reaching the same answer or not, it's a differences. Like a previous one, the energy showing here we understanding the regret of the distribution of the regret for each KPIs. Like a previous, the energy, it's a moderate. When you're moving to the IOHD, here it's increasing the distribution of the data and the differences between them, but the heat release is the most stable. In another part, we try to look at the three method for the optimization. In the first, we look at the performance optimize. So here we try to look at the lowest energy we can reach them. In the second one, we try to robustness optimize, and the last part we're showing the hybrid optimize. And based on that, we try to understanding, okay, if I using these three different methodology, we reach the same answer from the facade selection or not. We understand, okay, when you look at the robustness, when you move into the performance analysis, we have some cost. So we're losing some kind of the performance for this based on each KPIs for the different location. And we have some facade strategy. It's if you're using any kind of the methodology to optimization, it's always being the highest and the best facade is a low G value with the highest shading or the insulation, but for this specific case study. And also we're understanding some of this technology and the strategy we want to select it. It's not dependent based on the climate. It's based on the building physics. So it's showing the interaction and the conflict for the KPIs. But like any kind of research, we have some limitation here. It's most of these two research just focusing on the static. We're using the just ideal HVAC system with the constant COP and the SCR. So when you're changing the climate, we haven't considered the effect of the degradation on the performance of the HVAC. And also we ignoring the completely from the GH emission for the operational part. That's pushing us to showing, okay, we can extend our framework to the complex dynamic facade technology that can comparing them with the static one. And in the third one, we try to answer to these two remain after research question, the extending our work to the complex dynamic facade, and also including the effect of the HVAC degradation and grid decarbonization pathway. I try to move a bit faster based on the time. So here we creating some type of the facade with the level of the adaptation. So we considering, okay, and comparing with the two previous research, here we're moving to the multifamily. So from the zone level, we're coming to the building scales of the facade. And it's considering, okay, any kind of the building without shading. So we added in the another shading, but for the next part, we added in the adaptive shading and added in the adaptive facade technology for the opaque part. So we have an adaptation level for the different kinds. So adaptation for the glazing part, adaptation for the opaque part, and also the full adaptation or the full static. And we try to analyze different kind of the methodology. So give you some idea for the opaque part, we have a ZRAF technology that's developed by one of our colleagues in the Yorak Research Institute. That's a combination of the active insulation with the kinetic cladding. That's have a two different kind of the mode. It's based on the winter or in the summer mode. This kinetic cladding and active AIS active insulation system can be on and off or retracted or deploying. And for the glazing part, we're using the adaptive shading based on the some condition. It's the cooling season or the heating season or the occupant it's in or out, to try to controlling the opening and closing and also the angle of the shadings part to controlling as much as possible solar heat gain for the inside the buildings. Regarding the KPIs here, rather than just reporting one numbers, we considering the lifespan of the buildings. So rather than the showing, we have a 30 years lifespan of the building divided by the 215, and the first 15 years based on the current weather file we used, multiply by the 50, multiply by the variable COP and SCR based on the outdoor air temperature and also supply air. And for the mid-future, it's based on the mid-future weather files and the mid-future COP and SCR. So in this way, we import the effect of this changing climate on our result. In the next part, for the operational GH emission, most of the research, they just using the one constant number GH emission factor for whole of the lifespan. But here, in this research, based on the some another research, have a degradation of this GH emission. So for the each year, we have a specific GH emission factor based on the energy consumption we produce. And another part, rather than just using the IOHD for the whole of the process, we considering the climate change, our heating resistivity, just showing the how, if you're changing the outdoor air temperature, what's happening for the discomfort inside your building. So showing the slope of the changing and how we can quickly change our heating risk inside the building. And especially for the heat release in decomposition, in the two previous research, if you remember, we just reporting the total heat release. And this heat release, we didn't know, okay, which kind of the aspect, for example, it's going to the sky, going to the ground, going to the outdoor. But here we try to focusing and adapting this formula based on the engineering reference and also the mathematicals for the building physics, try to divide it based on the each component, and we are understanding some of this component, it doesn't contribution in the UHI. For example, when you go into the long wave radiation to the skies or the reflection from the building, they doesn't contribute into increasing the outdoor air temperatures. And here we try to understand, okay, when you added in the adaptation for the glazing or now for the opaque, what's happening for the building and how percentage you can decrease it. For example, when you added in the transparent adaptation from level 0 to level 2 for the each kind of the location, we have a different kind of the reduction in the energy, and most of the case going for the Torino. And for the opaque part, it's much more higher. It's between the 16 to 70% for the different location. And the full adaptation, we have a 32 reduction for the just energy. And when you're moving from the GH emission, we understand, okay, from the static GH emission factor methodology that currently used, compared with the dynamic one we are considering based on the each year, we have a different GH emission factor. We have a reduction more than 70%. But this changing from the just going to absolute value, so it doesn't have any effect on the ranking of the facade. And another part coming to the comfort, we try to understand, okay, this adding adaptation for the opaque and also for the glazing part, which kind of them for the which kind of the location have a much more effective. And this is helping us to creating the better control strategy to controlling the when is this AIS and kinetic cladding beam must be open and be closed, and when is the improving our discomfort inside the building. And from the heat releasing here, rather than the showing and comparing from the total numbers, because that's give us just the one vision and we ignoring, okay, how we can controlling this heat releasing from the building based on our technology. For example, the ZRAF technology, the mostly working based on the controlling the heat between the inside and outside. So we can shift it from the day to the night or based on the different season. So we using this knowledge to go in depth inside our technology to improve them and also creating the better control strategy. But we understand, okay, when you do if you didn't using the kinetic cladding to add it in the shading, the AIS based on the color completely be full in black, that's increasing the reflection and releasing heat from the inside to the outside more than 150%. So that's showing us, okay, how we can controlling the better days kinetic cladding for the technology of the ZRAF. So in this process, we try to understand, okay, if some components have some reduction for the another KPIs, but these KPIs maybe for the different location have a different time, but we ignoring the interaction between the 2 and 3 KPIs. So we have to adding them and using that knowledge to improving our control strategies. And this added in the GH emission factor degradation and also the HVAC system component, that's helping us, okay, they haven't any effect on the ranking of the facade strategy. But when you are moving to the HVAC system, we understand in this temperature dependent the modeling have a double effect for the cooling or have a double negative effect on the other KPIs when you're comparing with the just constant one number for the COP for whole of the year. So you're ignoring the effect of the climate change. But for the next part of the research, we want to add in also the embodied part to combine the effect of the GH emissions part. And if you want to look at the whole of the methodology, we are understanding, okay, we cannot treating as a climate as a just one specific time and using the just one single method to comparison and also the investigation. So we have to treat in the climate as uncertainty, and we look at them as a different methodology. And also we have to, it's better to doing the analysis for any kind of the strategy from the multi-scale and also the multiple performance, and try to choosing the robust design, comparing with the best case study. When you're comparing this, then you have understanding we have a lot of the cost. And added in the HVAC system and grid decarbonization as a time dependent, not just one number for whole of the years. But during these 3 years, I cannot cover all the aspects. So some part it's remained for me. For example, I didn't considering the effect of the extreme weather condition like heat waves. And one of our missing part, when you're using the heat release as an output, we cannot using as an input for the UHI calculation. So as a completing the loop of the building with the urban environment and backing them. Another part it's coming from I ignoring, so I didn't consider the embodied part of the different kind of the technology. So I just focusing on the operational part. And one of our approach when you're moving to the adaptation facade technology, we're using some constant control strategy. So the other part we now currently working on that, to using this knowledge to improving the control strategy, how we can use them as a loop to improving as much as possible. That's the whole of the work. And this research we try to contributing in the different the sustainable development goals, for example, in the SDG 11 for the sustainable city and community, with considering this heat releasing from the building, for the climate action when you're moving to the different future weather file uncertainty and regret-based robustness framework, to affordable and clean energy with adding the considering the variable COP and SEER, and also the grid decarbonization. And final part of the good health and industrial part with checking the real project of the ZRAF technology inside our methodologies. Thank you so much. I think
you very much for this excellent piece of research and for the wonderful presentation, bringing very complex contents to an understandable format. Excellent. Thank you very much. I would open the floor to our audience, and I invite you very much to turn on your camera so we can see your faces and raise hands if you have questions or comments to Milad. We would prefer raising hands better than comments written. So if you want to speak up, you're very much welcome. If nobody starts, I will start. I wondered, Milad, if you think for practical building design, if simulations, parametric simulations like this will, for the next years, form a basis for rules of the thumb. So will simulations like this improve the design rules, which then are still simple ones? Or do you think that technology, artificial intelligence, will boost the possibilities of simulations in that way that we will include simulations like this into normal building design?
Yeah. This is the one of my goals in the fact, because during this research we're understanding, okay, if I'm moving to the market, this process is too complex and also is not user friendly, especially the production of the weather file from the different aspect. And now as a postdoc, I'm working to the creating I can say the two main project. One of them is the production of the future weather files, and also the other different kind of the weather files, it's automatically for the different locations. So, but we have some limitation. For example, when you move into the dynamical downscaling, you need at least 5 years observation for that specific location you need them. So now I'm working on this part to solving this main gaps. Another part going to the post-processing of the result when you have a different kind of the KPIs. So some of these KPIs implemented already in the Energy Plus, so you can use it as output of directly, but you have to understand what's the goal of them. Another part, I try to develop some plugins for the Energy Plus and also for the Ladybug tools to the multi-objective optimization. So doing the post-processing automatically, and they give you the result. This is another part I currently work on that. And I try to reduce as much as possible the complexity and make it user-friendly for the user, mostly be architecture and designer companies.
I understand that you follow the track of optimism to say those simulation, building energy modeling, building comfort modeling should be developed as user-friendly as possible to become a normal design tool in everyday architectural or building engineering life. That's right?
Yes, okay. Exactly. That's our goals. During this research, we try to understand.
Mm-hmm. Mm-hmm.
And also another different methodologies, especially with I can say that during these 3 years, I learned a lot from the scientific part and also for technical parts, because I work as an architecture in the industry for a couple of years and understanding what's the vision of them. So if not be user-friendly and not be easy to use, they ignore it. So another part when you come into, for example, if you remember in the second research, we move into the full factorial analysis because we're learning the technique we can using the Energy Plus with some Python code to running the large number of the simulation in the parallel with a lot of the computer part to the, for example, we run 136,000 simulation in the 3 hours. So this is another methodology, is a technical methodology we learn to running large number of the simulation for the optimization with the simple computers.
Yeah. Another thought, do you think that there is a building has to be studied always in the combination of building design, so form, envelope, and material, plus HVAC systems, or can there be a robust building design that is true for very different kinds of HVAC and building service stuff, or is it always the combination?
No, they can use in the different kind of the approach. It's based on which level of the uncertainty you want to consider. For example, you can moving forward and based on this methodology, we understand, okay, we have some uncertainty, but rather than moving to the just selection the best strategy from the one specific method, you can consider the most robust against this uncertainty, but you have to consider that these most robust have some cost, so maybe have a differences with the best, but is the most stable. Because we didn't know, okay, which kind of this methodology in the future be materialized, but we try to change the mindset.
I like this approach very much, not going for a singular optimum, but for a robust basis. I think that is a very valuable outcome. As we're discussing, are there nobody out there in the world in the night and morning who wants to join our discussion?
I saw my supervisor is here. Nice. Thank you to him during these 3 years.
He doesn't. But he doesn't want to bring you in troubles with questions.
I would like to ask something, and you were talking about these strategies, these Seraph strategies, and could you explain a bit more which strategies or which like concrete measures are included in this? Because I You know, I'm also like I'm an architect, and I can kind of, if I can imagine what so is it this facade that can be,
yes,
you know,
this is the practical, and now it's the trying to testing in the real buildings. So it's coming from the development technology, now it's converted to the real component for the market, and we're working on the developing this technology. This technology is coming to combination of the active insulation system with the kinetic cladding. So they have a two different kind of the mode. It's okay, during the winters we try to observing as much as possible heat gain, and during the summer we want to releasing as much as possible. So based on the which time, which season in the beginning, and which time of the day, it's a day or it's a night, or now based on the sun, and now we're currently working on the optimization, this control strategy, how we can control them. But in the general, the idea is like that during the winter time, this kinetic cladding, especially in the day, or no, if the solar radiation it's going above the some threshold, or the air temperature it's above the some specific threshold, this kinetic cladding it's retracted to observing as much as possible, because we have active insulation with the darkest surface as much as possible, and active insulation it's on, so we in moving these heat gains to the inside the building. But another part, active insulation, so in the night we have a lower temperature in the winter, so this active insulation is off, so the U value it's increasing, and the R value it's increasing, so that's a resistance against this changing the heat transfer. So the most idea of this technology is to controlling the heat transfer between the outdoor and the indoor. So it's based on the different control strategy, and my colleague Ana Maria sharing the link of the this technology for the more investigation.
Okay.
In the summer it's completely reversed, so we in the day this deploying the kinetic cladding, so it's controlling as much as possible, reflecting this solar, and the active insulation trying to on and off, okay, to controlling, okay, which time we want to release in the heat, which time you want to observe in the heat. This is the main idea of the technology for the opaque part of the buildings.
Honestly, I heard the word of Seraph the first time, but it's impressive. And
yeah, it's really impressive technology, and one of the European founded project.
Yeah, and I like very much the wording of zero carbon building enabling facade. So I think this definition that something is enabling zero carbon buildings, it's a very straight and precise definition. Not saying
and
this
the next
is,
part, for example, we try to divide it, this heat releasing from the building from the different kind of the aspect of them to better understanding, okay, in the which day, which time of the year, which time of the day, which component of this heat release, it's higher or no, it's lower, or if it's lower or the higher, this component contributing to the heat release of the outdoor or not, because we didn't want to moving the heat to the pedestrian of the outside of the building and increasing the UHI's effect. So this also division between the pathway of the component of this heat release to give us this much more idea, okay, how is this system can be contributing to the UHI or not, or how we can control it better.
Very good. Great.
Yeah, thank you so much.
Nobody out there wants to turn on the camera and show who is behind. We are very curious. Ana Maria already outed. Oh, that's great. Khalili, hi. Any comments to the work of Milad? Yes, Anna Paula.
Hello.
Hi.
Hello.
Can I, yeah?
Yeah,
I
sure.
didn't raise my hand actually. Should I
Yeah,
raise
sure.
it first?
Welcome.
Hello, good night. Thank you, Milad, for your nice presentation. I just wanted to ask one question regarding, I saw that you also calculated overheating, right?
Yes.
Like indoor overheating. I'm wondering that if you also consider the short-wave effect of solar radiation to assess overheating inside in an indoor condition, or you just calculated like long-wave solar radiation to assess overheating.
For the overheating, the process be like that. So we're running the energy simulation based on the Energy Plus, and they give us the operative temperature. So all the aspect of the change in temperature, solar radiation, and also the different combination of the facade, they be considered inside the operative temperature.
Okay.
So I can say, okay, we consider all the aspect of the climate, and based on that, we consider, okay, we extract in the time its zone is occupied, and based on the adaptive thermal comfort, we have some threshold and we calculate the temperature above that. But all this aspect is considering just the operative.
Okay.
But this long wave and short wave, we try to focusing on the heat releasing part because it's the most important part for the technologies and also for this aspect because it's new for us. So we try to much more detail and considering the different part.
Nice, thank you.
I'm just shocked by the chat input from you, Fabio, telling us that there's a blackout in Torino based due to the cooling load. Wow! But the satellites of Wi-Fi are still working. Great, not great. Disturbing. Wow! Thank you for sharing this. Okay. If no more questions there, then I would again thank our speaker, Milad, for taking your time and sharing your research. I'm happy to know that you're connected to our annex task 97 and task 5, and we will work together on resilient cooling and sustainable cooling in cities for the next years. Looking forward very much. Hi, Wang. Okay, I would take over the screen for a farewell slide that is just telling that we look very much forward that you stay tuned. We will repeat this seminar series every 2 weeks, so you can count on that. We will invite interesting speakers with their interesting work every European evening, every 2 weeks. The next one will be Victoria Lopez Cabeza from Universidad de Sevilla with her input on thermal mitigation strategies of facades, roof, and vegetation, so green infrastructures. And after the next will be Dimitra Theokari. She's CEO from the company of Ensphere, with a very overarching input, overarching from technology, science, and art on ecology, comfort, and the unfamiliar city. So very interesting input, very overarching. And we're looking forward. You can always subscribe to receive special invitations to our colleague Tabea Wonnebauer at our institute. That's the Institute of Building Research and Innovation, in short, IBRI. If you want to, what is the opposite of subscribe? I don't know the word. If you want to do the opposite, you can write her too, but don't do this. We're happy if you join us. Okay. Having said this, I say thank you to all. Thanks for sharing this hour with us. Have a good sleep or a good morning or a good afternoon, wherever you are on this world. Thank you.
Thank you so much for all to listening and inviting us.
Thank you.
Thank you.
Goodbye.